evaluate. So we're going to be multiplying, adding, and subtracting with fractions. It would be best to convert any mixed numbers to improper fractions. So the way that we do that is we multiply the whole number 4 by the denominator 2. 4 times 2 is 8. And then we add the numerator, so that one is 9 over 2. And this one, 3 times 3 is 9, plus the numerator makes 10 over 3, and that fraction is multiplied by 2. So I have 3 times 9 is 27 over 2. 2 times 10 is 20 over 3. Now these are both not matching denominators, so the way we can change them into common denominators is multiplying this fraction by 3 and this fraction by 2. 3 times 2 is 6. 3 times 2 is also 6. 20 times 2 is 40. And 27 times 3 is 81. Then we can add 81 and 40 together, which is 121 over 6. For number 4, we have 1 times 4 is 4, plus 3 more makes 7 fourths, minus, we have 1 times 2 is 2, plus 1 makes 3, and that is being multiplied by 1/3. Well, 3 times 1 is 3, 2 times 3 is 6. 4 and 6 have a common denominator of 12. So if I multiply by 2, that turns a 6 into 12. And if I multiply by 3, that turns this 4 into 12. 3 times 7 is 21. 3 times 4 is 12. 3 times 2 is 6. 6 times 2 is 12. Then we need 21 minus 6 is 15 twelfths. Complete the warm-up on your own. How might we approach finding the area of the shaded region? Unfortunately, we do not have the side lengths or the base and height of the shaded region. An alternative method is to find the area of the entire outside and then remove the pieces that we don't want to be left with the shaded piece. Here, the base is 6 because it's a 5 and a 1 combined. And the height of this outer section is also 6 from the 5 and the 1. That's the outer rectangle. The triangles that we don't want have a base of 5 and a height of 1. But remember, for triangles, since they are half of the rectangle, we either multiply by 1/2 or we can divide by 2. Here is one triangle, that's 5 by 1. Here is another triangle, that's 5 by 1. A third, and a fourth. So I can subtract that 4 times, or I can multiply it by 4. 6 times 6 is 36. 5 times 1 is 5. And 5 divided by 2 is 2.5. Here I am going to multiply 4 times 2.5 because my order of operations tell me to do multiplication before subtraction. 4 times 2.5 is 10. 36 minus 10 gives us an area of the square in the center. The gray square is 26 centimeters squared. How might we go about finding the area of this shaded region? We have a large outer rectangle that we could start with, and then we could subtract the large triangle, the medium triangle, and the small triangle to be left with what's inside. Using that method, this has a base of 10 all the way across because 3 plus 7 is 10, and a height of 7. So the rectangle piece is 10 by 7, base times height. Then we're going to remove, this is also 10, and this also reaches a height of 7. But since it's a triangle, triangles get cut in half or divided by 2, and that takes care of this triangle here. To remove this triangle here, it has a base of 7 and a height of 2. And to remove this triangle, it has a base of 3 and a height of 7. Base times height divided by 2. And we're removing it using subtraction. 10 times 7 is 70. 10 times 7 is 70, and 70 divided by 2 is 35. 7 times 2 is 14. 14 divided by 2 is 7. 3 times 7 is 21. And 21 divided by 2 is 10.5. So if we subtract all of those from 70, we end up with an area of 17.5 inches squared. A different strategy would be to look at just this large obtuse triangle and then remove the small triangle from it. The large red obtuse triangle has a base of 7 and a height of 7. Since it's a triangle, we divide by 2. Then we will remove the small blue triangle. It has a base of 7, a height of 2, and triangles use the formula base times height divided by 2. 7 times 7 is 49. 49 divided by 2 is 24.5. 7 times 2 is 14. 14 divided by 2 is 7. And when we subtract, we get 17.5 inches squared, just like we did using the other method. But this one required fewer steps. So again, there are multiple ways to approach these problems, and you don't have to do it the same way that your partner or your neighbor does. You can still arrive at the same answer, as long as you follow an appropriate strategy and use the correct formulas. A rectangular garden measures 10 meters by 6 meters. So I know that the area of the garden is 60 because the base and height multiply together to make 60. A path 2 meters wide goes around the garden. So this distance is 2, and this distance is 2, and this distance is 2. What is the total area of the path in square meters? So I can find the area of the outer rectangle and remove the inner 60 meters squared from the garden to be left with the shaded region. Well, the garden, it was 10. Then I have 2 here, so 10 plus 2 is 12. Plus the 2 on this side makes the total width 14. The height of the garden was 6, plus the 2 here, 7, 8, and the 2 here, 9, 10. So the outer area, the base times the height, 14 times 10 is 140. And then we remove the garden to be left with the path. 140 minus 60 leaves us with an area of 80 meters squared for the path. Determine the total area of the shaded regions. We can find the area of the whole outer rectangle and then get rid of the 4 triangles that are not shaded. This outer rectangle has a width of 6 and a height of 8. Then I have a blue triangle here. It has a base of 2 and a height of 8. But it's a triangle, so we have to divide by 2. 2 times 8 is 16. 16 divided by 2 is 8. This green triangle also has a base of 2 and a height of 8, which has an area of 8. This small blue triangle has a base of 2 and a height of 2. 2 times 2 is 4. 4 divided by 2 is 2. And this triangle up here, the base across matches down here, which was 6. The height, the whole distance here was 8. But this bottom piece was 2. So what's left has to be a height of 6. 6 times 6 is 36. 36 divided by 2 is 18. So to find the area of the shaded regions, we will take the outer rectangle and remove the triangles we do not want. 48 minus 8 is 40. Minus 8 is 32. Minus 2 is 30. Minus 18 is an area of 12 meters squared. There are alternative approaches to this problem. Feel free to use those if you feel comfortable. Consider if you were to paint one of the walls of your classroom. Create an accurate drawing of the wall that needs to be painted. Label the measurements of the wall of your drawing. I'm going to do part A on a fresh slide so we have enough room to draw the picture. Our classroom is made up of a large rectangular wall. This wall, from the floor to the ceiling, measures 12 feet tall. From one corner of the room to the other side of the wall is 26 feet. In our classroom, we have a large door with windows next to it that would not be painted. So we have some windows on top and some windows next to our door. This whole rectangle, made up of the door and the windows, is 10 feet tall and 4 feet wide. There are also 2 large windows in our classroom that are rectangular in shape. And these windows are 6 feet wide, and they are 8 feet tall. On this wall, we also have a small exit sign that is 1 foot wide and a half a foot tall. Part B asks us to calculate the area of the wall that needs to be painted. So we know that we're going to start with the whole 26 by 12 rectangle. Base times height. But we're not going to paint, so we're going to remove the door with the windows. The base is 4, the height is 10. We're also going to remove the exit sign because we don't want to paint over that. The base was 1, the height was 0.5. And we're going to remove these 2 windows. The base is 6, the height is 8. We will multiply in our parentheses first to follow our order of operations. 26 times 12 is 312. 4 times 10 is 40. 1 times 0.5 is 0.5. 6 times 8 is 48. And again, 6 times 8 is 48. So the whole wall, if we were to paint, would be 312. But we're not painting the door. We're not painting the fire or the exit sign. We're not painting the windows. Which leaves us with 175.5 feet squared. That would be our answer to part B. Part C says 1 quart of paint covers 80 square feet and cost $16.99. How much does the paint required to paint the wall cost? Well, let's see. In order to figure out how many cans of paint we need, we would divide by 80. If we divide this answer by 80, we get approximately 2.194. But the problem is, we can't just buy 0.19 of a quart. We have to buy them in its entirety. So even if we're only going to use a little bit of the can of paint, we still have to buy 3 cans of paint. And it says each can costs $16.99. So if we need 3 cans and each one costs $16.99, we're going to multiply that price by 3. $16.99 times 3 is $50.97. If your teacher has provided you with a sketch of your classroom wall, you can use similar strategies to help you solve for the area of your classroom wall. Otherwise, feel free to use the looks of our classroom.